We are going to be solving some systems of equations that have three equations and three different variables. So we're going to solve them simultaneously to get one single point in which these three equations, which actually give you the graphs of different planes, are going to intersect at one point. You can see an illustration of what this looks like in your book. So I have these three equations, and I have z at the bottom is equal to 2. So what I'm going to do is I'm going to substitute that into the second equation, which just has y and z. I'm going to get 3y minus 4 equals negative 1, so 3y equals 3 and y equals 1. Then I'm going to take y equals 1, plug it into the very first equation. So x plus 2 times 1, which is just 2, plus 3z, which is going to end up as minus 6 when I plug in my z is equal to negative 2 is equal to negative 1. And then I get x plus 2 minus 6 is equal to negative 1, x minus 4 is equal to negative 1, x is equal to 3. Now, because this is a point, I'm actually going to write it separated by commas in the order of x comma y comma z, and I get 3 comma 1 comma negative 2. So what I see here is I see this triangular pattern, right? The first one has x, y, and z. The second one has y and z. The third one has just z. And this is what I'm going to be going for as I solve an equation, or as I solve three separate equations, right, that all have x, y, and z. I'm going to try to narrow them down so that the last one just has z, the second one has y and z, and the top one has x, y, and z. So what I'm going to do is I'm going to put these equations into a matrix. And what I'm going to do is I'm going to take the coefficients of each equation and put them into my matrix. So I have 2, 2, 1, 3, 3, 2, negative 2, negative 1, 5, negative 2, negative 6, and 17. So what I'm going to do is I'm going to try to make this triangle be full of zeros. And in order to do that, I'm going to do what's called a linear combination. We've done this before with two equations, two variables, but now I'm going to be doing it with more. So what I'm going to do is I'm going to add two of the lines together with the goal in mind of making one of the numbers in that triangle equal to 0. So the first thing I'll do is multiply the top equation by 3, or the top row by 3, and then the entire middle row by negative 2. And if I do that, then I end up with 6, 6, 3, 9, when I multiply the top row by 3, and then negative 6, negative 4, positive 4, positive 2. So what this is allowing me to do is that if I add these two rows together, the top row and the second row, row 1 and row 2, then what happens is the 6 and the negative 6 are going to cancel. So I'm going to replace the middle row with the result of adding row 1 and row 2. And I'm also going to change row 1 back into its original form with 2, 2, 1, and 3. Now the middle row is going to be 0, 2, 7, and 11 after I add row 1 and row 2. And then I'm going to rewrite row 3. Just as it was. I forgot a negative there, so just as a reminder, I'm putting the negative back there. It's going to disappear later. Anyway, so the next thing I'm going to do is I'm going to add row 1 and row 3 together, but first I need to multiply the top one by negative 5 and the bottom one by 2, because in the top row I'm going to get negative 10 as my first term, and in the bottom one I'm going to get positive 10 as my first term. And then once again, I forgot a negative there with the negative 12, so I'm going to add that in a moment. But anyway, I'm going to add row 1 and row 3 together. So I end up changing my row 1 back to what it originally was. Originally it was 2, 2, 1, 3, so I just change it back. Always change it back. You just kind of change it temporarily so you can add things. So you get 0, negative 10 minus 4 is negative 14, and then negative 5, which would be, now I'm correcting this mistake, minus 12 is negative 17, and lastly, negative 15 plus 34 is 19. So I get that complete matrix, which I'm going to rewrite on the next page. So let me just quickly write this. So again, we're kind of going through this step of, okay, I'm multiplying different rows by something so that I can kind of get their numbers. The thing that I'm trying to make 0, right, or the location where I'm trying to make 0, I get it to be the same number, but opposite sign as the row that I'm adding it with, right? So if I look at this one, what I want to do is I actually want to get that negative 14 to be 0, so I'm going to multiply the middle row by 7 in order to make it positive 14. That way, when I add it with row 3, the positive 14 and the negative 14 will cancel. So I still have 2, 2, 1, 3 in the top. I have 0, 2, 7, 11. I'm changing it back there. And then I have 0, 0, 0, and then 49 minus 17 is 32. 77 plus 19 is going to be 96. And then lastly, you might do one more row where I realize that 32 can be divided by 32 and 96 can also be divided by 32. So I'm going to divide row 3 by 32 so that I end up with 1 and 3. So this is going to turn back into some equations. So I have 2x plus 2y plus z is equal to 3. That was the original first equation. And then now I have 2y plus 7z equals 11, and z is equal to 3, right? That triangle of zeros made me basically say I have a 0x plus 2y plus 7z, etc. And I have a 0x plus 0y plus z equals 3, but you can just eliminate those 0x's and 0y's. So what I'm going to do is I'm going to plug in z equals 3 into the second equation, solve for y, I get negative 5, and then I plug in negative 5 for y, 3 for z into the very first equation, and I end up getting x is equal to 5. So my total solution is 5, negative 5, 3. We're going to do another one. I'm just going to quickly write this at super speed here. Yes, my hand was moving this fast. Just kidding. So I have the coefficients that I'm going to write in 1, 3, 4, 6, 1, negative 2, 1, 10, and then 2, 3, negative 1, 0. So the first thing I want to do is I want to get that first, in the second row, I want that first number to be 0. So what I do is I do row 1 minus row 2. So 1 minus 1 is 0, 3 minus negative 2 is 5, etc. And then I'm just going to rewrite row 3. Now I'm going to try to eliminate that 2 in the third row. I'm going to make it 0. So I'm going to multiply the top row by negative 2 so that it'll have an opposite sign in the first term as my row 3. So then I'm going to add row 1 and row 3. I end up changing my row 1 back to what it was before. And then I still have row 2 the same. And now my third row is 0, negative 3, negative 9, negative 12. And you might notice here that I can divide row 3 by negative 3 because those are all divisible by negative 3. And I end up with 0, 5, 3, 4 still in the second row. And then the last row is going to be 0, 1, 3, 4, which is going to make it a little bit easier to work with. So I'm going to multiply the bottom row by negative 5. Why? Because I'm going to add it with row 2, which has a 5 in that same location, so that I end up with opposite signs right above each other, right? I have 5 and negative 5, which are going to add to be 0. And I do want that location in row 3 to be 0. This is exactly what I want. So that ends up with 0, and then 0. Negative 15 plus 3 is negative 12. Negative 20 plus negative 4 is negative 24. And then what I'm going to do as a last step is divide that whole row, row 3, by negative 12, which ends up as 1 and 2, which means that z is equal to 2, right? That last row gives me an equation z equals 2. The top row is still the original equation. Also, it should have been a, b's, and c's, but I forgot about that. So let's just pretend they were x, y's, and z's for now. So we get z equals 2, and I plug that into the second equation right above it, and I get 5y plus 6 equals negative 4. Therefore, 5y is equal to negative 10, and y is equal to negative 2. And then I'm going to plug in negative 2 and 2, right? My y and my z. And for the very first equation, I end up with x is equal to 4. So my final solution is 4, negative 2, 2. Good luck on your homework, and have a great day.